Okay, good morning or afternoon, everyone. I'm going to begin now. So today I'm going to give a short webinar on the Blueback Geodata Investigator, or GDI. My name is Bruce Chalmers. So today we're using the GoToMeeting hosted session. You can open and close your panel by clicking this orange icon and expand it back again to use any of the features. You can view in a window or full screen by adjusting the mode there under view. By default everyone is muted, but you can ask your questions through this dialog, and we'll take some time at the end to go through them. Like I said, we'll have a Q&A at the end, and we'll hopefully post a link on the website within 24 hours. And just to show you that, if you're not aware, if you go to bluebackreservoir.com, you'll see a link to the Media Center on the right-hand side, and here you'll find links to all our webinars, YouTube videos, and guides to software products. But for this afternoon, we're going to focus on the Geodata Investigator, which is our multi-domain cross-plotter for Petrel. Some of the key features in the version number 2 is you can plot many dimensions in the matrix window. You can create equations and statistics for your data to get a quantitative understanding. And now you can also interpret the data through the crossplots. So here we show all the different data types that we support, and that we add a number of different windows inside of Petrel. Rather than bore you with a bunch of slides, I'm going to go through a couple of different workflows using the GDI. I'm going to show a geology type workflow covering some interpretation and analysis of well data. I'm then going to cover a more property modeling and reservoir engineering workflow looking at well data together with model data. And then I'm going to cover a couple of geophysics workflows looking at some seismic data, and finally some more rock physics type workflow. So let's just jump into Petrel and get started with that. So here from Petrel, I can start GDI by saying insert new Blueback GDI investigation, and up pops my investigation. By clicking the starburst option here, I can start to select the data that I want, and you can see the range of data that we have supported. So I can choose, for example, wells, and then I'm going to select a couple of folders, A wells and B wells. I can give a name to this folder of data like AB wells, just to know what I'm doing. And I can then start defining different dimensions that I want to add to my plot. So firstly I'm going to choose porosity, and then I'm going to add in a couple more continuous dimensions, so permeability and also gamma. And in addition, I can add in a discrete template, and I'm going to use Fishies. You can see here that you get a relevant filter for well data if you want to constrain between well tops. In addition, you'll find a second tab here called Dimensions, where you can apply overrides to the units, min and max, and the names of the data. So if I wanted to rather call this one K and this one GR, it's easy to define these things as part of the investigation, so you don't have to go through it every time on your plot. And in addition, you can define here the min and the max for this range of gamma ray, for example. Let's just press OK and create that. So the first thing I'm going to show is the new matrix window, which you find by going Window, New Blueback Matrix Window. And then what we do is toggle on the investigation, which I find here. And this window gives me a plot of every dimension that I've defined against each other. So first I have porosity versus gamma, porosity versus permeability, and then porosity versus porosity, which is rendered as a histogram. So for however many dimensions I've selected, I get a plot against each other dimension and also itself, and that lets me see trends in the data and how different clusters of data might behave across different classes. I can, for example, color by gamma ray, for example, and then I can see the color across all the different plots. I can also right-click on a plot and say, for example, toggle points color scale, which turns on the legend for the gamma ray. I can also color, for example, by my discrete data, so in this case my Fishies, and again I can add a legend to my plot. I can interactively turn on and off the Fishies that I'm, say for example, not interested in, and let's focus on the single sand Fishies. And then I can quickly QC how this single unit is behaving across the different dimensions and see how it's splitting into different classes. I can click on a single point here in any of these plots and it will highlight that same point in any other dimension, and likewise I can also add a small selection here, in my case a rectangle, and it will select the same data across all of the different dimensions. If I find a plot I'm particularly interested in, I can also expand by double clicking. Say for example here I have my porosity versus permeability, and if I want to go back to the regular matrix window, I simply just double click and I go back to the other matrix window. Let's look at the crossplot now in a little bit more detail. So I'm going to say Window, New Blueback Crossplot Window, and again toggle on the same investigation. And this shows how the investigation saves you a bit of time when plotting the same data in different ways. So I don't have to go back and reselect all my data again. I can just pick up the same investigation. I can change the axis here again by right-clicking and say set to gamma ray, and I can change the visible axis. So now I have porosity against gamma ray. And I want to show you a new workflow in GDI2 which allows you to not only plot data but to actually interpret it. So I can do that by opening the investigation, choosing classification groups and creating a new classification. Let's call this one Bruce's, and create a new one called Bruce's Fishies. And here I can pick up a Petrel template or define a new one, for example, and I can use whatever system I want here. I could say sand or shale, sand, shale, carbonate. I could say pay versus non-pay, or in my example I'm going to say good versus bad, and then just press OK to create that. And then what we do by defining some classified regions using freehand or rectangle, for example, we can cluster the data together into different classes. So let's make one here and a second one like so, and I can then assign them. So this one I'm going to say is good and the second is bad. I can check my interpretation by coloring by this, and I see my interpretation here, and I have a zone of overlap between the two. I can adjust the priority on the overlap by moving this one up here, press OK, and I then get this overlap changed based on that priority. To output some data based on this interpretation, I simply right-click and say for my folder of wells, save as a classified well log, like so. And then if I come to my Petrel well section window, I can toggle on my wells and find my Fishies interpretation here for each of the wells. So this lets you create data from your investigation which can then be further used in Petrel, for example in mapping or zone strat attributes, and you can take this a little bit further. I'm just going to complete the story here by then adding my interpretation into my investigation. Press OK, and then I'm going to show the histogram window, and again toggle on my investigation and this time I'm going to color by my interpretation and produce some statistics of my interpretation. So here I have the porosity of my interpretation, and then it's split into my two different classes. In this histogram we can also color by the data, for example, and by right-clicking we can say color by children, and this will give us a histogram composing of the different wells that make up my investigation, and I can get my statistics for each of the wells. So now I'm going to move on and show you a little bit of a more modeling and RE workflow. So I'm going to say insert new GDI investigation. I'm going to add some wells. This time I just choose the A wells, and I'm going to define porosity and permeability. But in addition, this time I'm also going to add a model and select porosity, permeability, and in addition I'm going to add some fluvial facies to this, and let's get that for the wells, and then just press OK. I'm going to start by showing this again with the histogram window. So the first thing I might want to do is to QC my model versus my well data to see that the model has incorporated the right trend in the data. So what I can do here is separate the data into different overlapping classes, and you can see how the two trends compare. But of course with a model in the view it's important to use the weighted percentage, and I can see how the trend in the well porosity compares with that of my model. In addition, I can also color this by the different facies, like so. Let's stack them, and again I can get statistics on each of the facies from both sets of data here, but I can also interactively turn off, for example, the wells and update my histogram accordingly. So now I just have a histogram of my facies from my model. I can also turn off interactively the facies that I'm not interested in, leaving only the ones I want here with my statistics, and I can also display my cumulative distribution functions for these facies. From the histogram window, it's also important to show that we have some good export possibilities. So here we can directly export to a spreadsheet, and if I open my exported spreadsheet here, what I get is a tab for the histogram. So here's the porosity histogram with all the bins, the statistics, and the cumulative distribution functions. I also get the raw data. So here my geogrid, I'll find my porosity, permeability, facies, IJK, segment, etc. And then I get the raw well data. So the process of creating an investigation and a histogram also allows me to create this nice Excel-friendly spreadsheet, which I can then use in some further data analysis processes inside of Excel. Just moving back to Petrel, I want to show then the Crossplot window with my well data and models. And what I can do here again is color by facies, for example. And here I see that I have a white color, which is not a great contrast against the background. So by right-clicking on a point, I can say change the point symbol to a circle with a border, for example. And also by right-clicking, I can then adjust the size. So I get a nicer plot of my model data here. By using a selection inside of the Crossplot window, in this case a rectangle, I can also then create some objects which allow me to visually integrate with the real data. So I'm just going to close these windows here and then open a new 3D window. So from inside of the crossplot, I can produce something called a dynamic point set. which I can then display in the 3D window. And what this is a point set of my data I have selected here, and I can show that it's dynamic by adjusting it slightly, and it updates. But what I also get when I create this point set is all the attributes in my investigation. So by changing this setting here, I can color, for example, by porosity or even Fishies. When I have a selection like this, it's also possible to, again, by right-clicking, produce a indicator property, which is like a true or false. So in this window here, I can show my indicator property, which is true or false based on my restriction in the crossplot. So this allows you to create a property or a well log based on your restriction, which can be then used as a filter against other calculations in Petrel. I'm just going to show how you can then further use the Crossplot window here to apply some equations. So first I'm going to filter by some of the Fishies, just leaving a few that I'm interested in. And what I can do here is then say create equation, which can be either static or dynamic. So if I create a dynamic equation, for example, I get a best fit equation applied to this data. But because it's dynamic, if I then create a filter around some data, the equation will update based on that selection. So I can move my selection around, the equation will update. If I'm happy with my equation, I can right-click on it and say save as static best fit and keep that here. And then I can, for example, bring back some of the data, Fishies, etc., to create a new best fit for a new set of data. So this allows you to create some quantitative relationships for different parts of the data set. Next, I'm going to show how we can also bring in some data from Excel. So here I have my data, porosity and permeability data that I may have gotten from some other analysis. So by opening my investigation and choosing to add table data, I can, for example, grab firstly my porosities and then my permeability. Press OK. And this allows me to see my table data versus the model. Let's just color by data. If I turn this model off, and then what I want to do is to adjust the size of the points here. So right click and say table data. Let's make it size 14 and make it a box with a border. I can then take my data from Excel and compare that with my data from my geological model here. So having the GDI is a really good bridge between, for example, Microsoft Excel and, of course, the data in Petrel. Now it's time to move on to some more geophysical workflows. So I'm first going to start by, again, creating a new investigation. This time I'm going to choose seismic as my input data. I have to choose a geometry as a guide, so I'm going to say near, and I'm then going to add my near, mid, and far data. Press OK. And then again show my new matrix window and toggle on my investigation. And here you can see a very basic plot of near versus mid, near versus far, etc. And this can be used as a quick guide to investigate if you have any AVO response in your data. On my near versus far, I can see that I have a really nice response that's worth investigating. So I'm going to take it a little bit further now and do that next step. So I'm going to create a new investigation here. Again, choosing seismic, and this time I'm going to choose my intercept and gradient cubes, and I'm also going to add in a far. Press OK, and open a new Scatterplot window and toggle on my investigation. And here you can see I have a kind of nice tight background trend here with some anomalous points to the left. I can confirm that by coloring by far, and here again you see a nice background trend in the data with an anomaly starting to build up on this side of the graph. So it's important to know where that anomaly is in the real world space. So again, I can choose, for example, a freehand filter, select some points like so, and then produce my dynamic point set. And by choosing a 3D window in Petrel, I can display my seismic here, and then toggle on my dynamic point set. And here you see my points nicely matching my anomaly down here in the base of the seismic. So even though there are some nice bright amplitudes up here, it doesn't correspond to this anomaly on my plot. Again, you can see this is interactive. As I move the restriction, the point set updates in real time, and you can understand the real world position of your data. Now I'm going to show one more geophysical workflow based on well data, which is more appropriate for rock physics. So again, I'm going to create a GDI investigation. This time choose a single well, my Jura well, and I'm going to choose this time VP, VS, density, V-shale, and also my Fishies. Press OK. And what I'm going to show is a new plot in GDI2, which is a parallel coordinates plot, which is just a unique way of showing trends in the data. So again, toggle on my investigation. And what this plot does for each sample in your investigation, it draws a connecting line between the different dimensions. So here I can see a clear trend between density and V-shale. And this becomes much more apparent when I, for example, color by my facies, and you can see the sand following a very consistent trend in its properties across these dimensions. I'm going to explore this a little bit further by creating a scatter plot using the same investigation. This time I have VP versus VS, and then I'm going to color by V-shale, and again by right-clicking I can say toggle color scale. So I have a cluster here of low V-shale and highs. In this mode, what we can do is overlay our rock physics equations. So here I have friable sand, which matches up quite nicely with my data. If I change the axis here from S velocity to density, I can then overlay some more rock physics equations, and in this case I can overlay my empirical Gardner sand and shale equations. So here I can see that I have quite a nice fit with sand and shale by overlaying my two equations here, and this gives me a lot more confidence when applying some more theoretical rock physics workflows to this data. Next I want to show one more final step of what we can do here in GDI. I can color my data by, for example, facies, and then let's just toggle off everything but sand, and let's get rid of these equations. I can also create a selection around here, a freehand filter, and I can then contour the data that I have by my facies, and I get a nice contour set around my sand facies here. I can then export this as a probability density function, and what this allows me to do is to produce two or multiple probability density functions for my different facies, which can be then used in a number of classification workflows, including part of the toolbox a Bayesian classification workflow, which uses these probability density functions. So that's everything I wanted to show as part of the demo. I'm going to give a small recap in some slides. So hopefully today I've shown that it's quite straightforward to create an investigation using multiple data types and dimensions, and that this one investigation can then be rendered in a number of different windows with relative ease. I've shown that the GDI has different ways of visualizing data. So we have matrix plot, histogram, and parallel coordinates plot, which can all expose different elements in your data. I've shown that you can work with different data types together. So in my example, I used a model together with well data. I've shown that due to its interactive nature and usability, it's really easy to work with different data types and dimensions in GDI. You can easily toggle on and off data from your investigation, and also certain Fishies or discrete properties that are not interesting to you when making your display. I've also shown that through the matrix plot we've added good support for working with multiple dimensions. So you can choose any number of dimensions of data and visualize them together in the matrix plot to help you understand how trends in the data change across your different dimensions. I've also shown we can add an extra level of context to the data in the matrix plot by coloring by discrete properties, in this example Fishies. I've shown that you can then interpret the data by using classifications. So this allows you to use rectangles or freehand polygons to put the data into different classes and then output a usable Petrel object that can then be taken forward into further operations inside of Petrel. In this example I showed a well log, which you can then use in calculator in various mapping operations, etc. I've shown that by using equations you can quickly establish quantitative relationships between different properties, and again you have the choice of creating static or dynamic equations which can be used to QC data before you make the equation. I've also shown that using the histogram you can produce statistics for the data, including min, max, mean, standard deviation, and also any number of cumulative distribution functions. I've shown that you can visually integrate with the data by using, for example, the dynamic point set, which shows the point set of the data in real time. And I've also shown that you can use indicator objects to produce data in Petrel that can be used as a filter or a constraint in another operation based on your crossplot selection. I've also shown that you can export the data in many different ways. So we have the option to export as a spreadsheet, which gives a really nice pre-formatted Excel-friendly spreadsheet, which is ready to be run through different further statistical processes. We can also at any point save as a regular point set, which can be used in Petrel for many different operations. We can also save as a raw crossplot, which is a way of converting a GDI crossplot into something that can be used as a condition in petrophysical modeling. We have some easy bitmap and EMF exports, so you can quickly get your graph over into Excel, or PowerPoint rather. And they're showing that we can create a dynamic point set of our investigation. So that brings us towards the end of this webinar. We support free evaluations for GDI, which can be obtained by contacting sales@bluebackreservoir.com or alternatively through the Ocean Store. The price of a GDI is $18,000 for 12 months, but there's also a bundle price together with the toolbox and the rock physics for our customers who use those existing products. I'm now going to refer to the questions panel in the GoToWebinar to see if we have any questions. So now's the time to pop in a question if you have. Before I start with that, I'll just would also like to say thanks very much for joining today. So if I look here at the questions. Okay, there doesn't appear to be any questions. I'll just give a couple of minutes more to see if anyone has a question.